Vx is going to equal, I want to multiply the 4 up. Vx is going to equal 4 cos 60. What is that value? Alexis is already going for it. 2. Beautiful. Gernavin, have you started any trig stuff in IB? Or is that next? Are you IB next semester? Okay, then never mind. So we've got a value for Vx. Vx is 2. Let's find Vyi. I'm going to go up. I'll do it up inside here. And we're going to have, you know what? No, I'm going to do it over here. Because Vyi is opposite, and we're going to use the hypotenuse, I'm going to use SOA, or sine now, for this piece. So we're going to have the sine of theta is equal to now the opposite side divided by the hypotenuse. Fill this thing in. The sine of 60 equals the opposite, which is our Vyi over 4. I'm going to multiply both sides by 4. So we're going to get Vyi equals 4 sine 60. Alexis, if you would, please. Okay. Thank you. So now that is our Vyi, 3.46. We can fill in a few more things we know. We know the acceleration here is, I'm going to call, because we're angled now, I'm going to call right and up positive, which is going to make our acceleration negative 9.8 meters per second squared. That's in meters per second, and this is meters per second. And so far, that's all we got. Anyone want to take, well, let's do it this way. What could we find based on this information? What are the kinds of questions I could ask? Yeah, here, Dad, give me one. How long did it take? T. We could find that. Okay. What else could we find? Which one? There's 2. We're in 2 dimensions now. Horizontal distance. That makes a lot of sense. Okay, so let's find those 2 things. Finding time is going to be the important one first. There are 2 ways to tackle finding the time here. We have kind of talked about them already. Because time is going to be found, well, I'll say it this way. How do we have to go about finding the time? It's related to something we've already looked at. What determines how long the thing stays in the air? I'll give you a hint. If this weren't there, it would never come back down. Gravity. And gravity is acting vertically. So the portion of the problem that is going to impact this is the vertical component. We need the only way we're going to find time, given the information that we have here, is this. So there's 2 pieces of information in this direction we don't know. We don't know how high it goes. There's 2 other things we know, but they're not labeled. What else do we know here? There's 2 pieces of information that we know, even though we haven't labeled them. Yeah, here it is. Sorry? Vertically? We do not know the vertical distance. Sorry? We can't know that until we know how long it took. We know Vy final in 2 places. Where do we know Vy final? Sorry? At the bottom? Okay, so what is Vy final here, half to V? Over level ground, there's something significant about that. Correct. Because this is level ground, this statement right here is true. The Vy final is going to equal the negative of Vy initial. So how fast was it coming down at here day? Well, if it was going up at 3.46 meters per second, it's coming down at negative 3.46 meters per second. The other place that we know Vy is where? At the top. Right there, we know that Vy is equal to 0. So there's two ways you can tackle finding the time. You could find the time to the top and then double it, or you could find the time beginning to end. Remembering that for over level ground, this is true. Vy final is equal to negative Vy initial. Two ways you can do it, doesn't matter which way you choose to tackle it. So I'm going to do it this way. Now we've got a Vy final of negative 3.46, and that's only true because we're over level ground, and we can go ahead now and find the time. This is a really simple equation. We've got an initial velocity, a final velocity, an acceleration, and we're looking for t. So this kinematic equation is V final equals V initial plus AT. It's arguably the simplest of them. So it's going to be negative 3.46 equals 3.46 plus negative 9.8 t. So now the mistake I see students make here all the time is that they say, yes, I'm going to move the 3.46 over, and the answer is going to be, what's the mistake the students make? Yeah, they're going to say this is 0. Is it? How do I move the 3.46 over? It's positive right here, so I'm going to subtract it over. So it's going to be negative 3.46 minus 3.46. It's going to be negative, what is that? 92 equals negative 9.8 t. So now I'm going to divide this thing by negative 9.8. I'm going to divide by negative 9.8, and we're going to get a time of what? Point what? 0.70? Okay. Now all we've got to do, bring in this. So we found the time. Now this is the total flight time. Because we used Vy final to be negative Vy initial, this is total flight time. So now all we've got to do is take this and bring it up here. The horizontal range then is going to be d equals v times t. So this is going to be 2 times 0.7. That gives us a horizontal distance of 1.4 meters. So clearly, this is not an accurate reflection of the throw that I made to here day, because he's a whole heck of a lot further away from me than 1.4 meters, which means this number is low. But that is the procedure. We found now the horizontal range and the total flight time. Even if this is the first time you're seeing trig, none of this is conceptually very difficult. As long as you can And that's the hardest part with physics, especially physics 11, is to slow yourself down and be able to break it up piece by piece. If you can do that, the skills required to do this aren't demanding. It's the slowing yourself down and batching it, parsing it out. Questions about anything I've done here? Okay, then I'm gonna do one more. Okay, we're gonna make this more interesting. By more interesting, that always means harder. I hope you've got some space at the bottom. If you don't, then you're gonna need some spare space. Here we go. I'm gonna draw a horizontal line across here. I'm gonna go elevated. So from some height, we've got an object launched, angled. It's going to travel. It's going to impact. Now, insert your scenario here. A particularly stupid example is one that my buddies and I did back in high school. We thought it would be fun to try and catch golf balls. So a buddy of ours stood up a slightly elevated hill. We were out on the football field during spare, and he was lobbing golf balls at us with his driver. I took one to the thigh. It hurt a lot. We were stupid, but this is what we did. So the procedure is going to be similar. We could find, there's a lot we could find, depending on the information that we're given to start, there's a lot that we could find. We could work those questions, depending on how, like I don't want to take the time to do more than one example of these, so I'll leave it to you to tell me how you want me to play this up. The two kinds of examples I could pose to you are something just like this, where I give you an initial velocity that it's punted out. I could ask you for flight time. I could ask you for horizontal distance. Or I could give you a slightly more, well, maybe not real world, but we could measure this distance. We could know this height, and we can work it backwards and actually find the velocity with which this thing left. I'm going to do one example. You tell me which one you want to see. Hands up for, let's play it exactly the same as we did for level ground and find range and time. Hands up if that's what you want to see. Hands up for, let's go the other way and find out how fast this thing had to leave given this information. Wow, so no engagement. Where is it, guys? Iyad, what do you want to see? Just Kirit, what do you want to see? Akash? Syra? Gurnavan? Hirday? Which one do you want to see? Sorry? Okay, here it is. He's abstaining. Lena? Alexis? And first. Okay, let's do the first one. Given a piece of information we know. So we're going to crank these numbers up here a little bit. We're going to make this thing 50 meters per second, which is a lot more accurate for a golf ball. And we're going to angle this thing at 30 degrees. Over level ground, we had the very beautiful fact that we knew what the VY final is. Not over level ground, we can't know what this is going to be because gravity is going to be able to pull down on this thing for a greater amount of time than it was rising for. So you stay on this page. I want to flip something back. If you were to recall this page, for a ball thrown vertically upwards, we were able to break it up one of two ways. We could say, look at ball goes up, look at ball comes down, combine those things. Or we could say, beginning to end, here's the quadratic formula, use it. You like this one? There's going to be two classmates of yours that don't have that. So, well, it's easy to use, but the physics is a little bit more. This is another step up. So when you were angled like this, my recommendation, if you want to use the quadratic formula, I'll let you play with that on your own. For the sake of the space that I have available to me, I'm going to break this thing up into two problems. I'm going to break this thing up into up to the top, here to top is going to be my first part of the problem, and the second part of the problem is going to be top on down. If you've got the quadratic formula, you don't need to do this. If you've got the quadratic formula, all you need is to know the vertical displacement, which we're going to say that this is 60 meters. And with this, you can, with the quadratic formula, you know what, Liam? Why don't you do it with the quadratic formula while the rest of us don't? The rest of us are going to do it the brutal way, to the top and then to the bottom. The only difference here, so this 60 meters, I'm going to call to the right, and I'm going to call upwards positive. The only difference between Liam, between what we're about to do and what you're going to do, is if you choose to try it, is this is going to be your displacement down. Because displacement does not care what happens in between. It just cares where you start and where you end. The ball starts on the building, it ends on the ground, your displacement is negative 60. We can't do that because we're going to break this thing up. If you don't have the quadratic formula, you've got to break it up this way. So we've got x, we've got y. The way the trigonometry works is that every time for Vx and for Vy, you're going to get these two trig ratios coming out this way. So for Vx, instead of being 4 cosine 60, it's going to be whatever the velocity was cosine whatever angle this is. So this is just going to be 50 cos 30, because Vx is the adjacent side. Vy is this side here. Vyi is going to be 50 sine 30. So I'll give you the values for the sake of time. I've got these values calculated. 50 sine 30 is 25. That's your Vyi. And Vx is going to be 43.3. We know the acceleration horizontally is 0. The acceleration vertically is negative 9.8 meters per second squared. If you don't have the quadratic formula available to you, now you've got to break this thing up into 1 and 2. For part 1, we know that V final y has to be equal to what right there? 0. And so we can use this information to find two things. We need to use this thing to find the time to the top. Sorry, T top. And we need to know how far vertically this thing travels. We need D to the top. The kinematics are fairly straightforward. We've got an initial velocity, we've got an acceleration. We know the final velocity, we're looking for T and D. So to find T, we're just going to use Vf equals Vi plus At. Vf is 0, Vi is 25, A is negative 9.8, and we can find T fairly straightforward. In fact, T top, we're going to subtract the 25 over, we're going to divide it by negative 9.8, and we're going to get that this value is 2.55 seconds. That's the time it takes for the object to reach the top of its path. Now we also need to know how far vertically the thing travels, because for the second part of the problem, it doesn't start at the cliff height, it starts elevated because it's traveled up. So we need to find d top. And to do that, we're going to have to use VF, VI, and A. So that kinematic equation looks like this. VF squared equals VI squared plus 2AD. VF is 0, VI is 25, and we're going to square it. Plus 2 times negative 9.8D. 25 squared is 625. I'm going to subtract it over. I'm going to divide that by 2. I'm going to divide that by negative 9.8. And for the sake of time, I'm going to tell you that d top is equal to 31.89 meters. That's just this part. Liam's probably done his part. So now we're going to go top to bottom. The second portion of the problem. For the second portion of the problem, A is still negative 9.8. But now what's VI? At the top now, if we ignore what happened before, top is 0. This portion of the problem is exactly the horizontal parts. That's it. VI is 0. We now know, though, the total displacement now is going to be the 60 meters it was, plus the 31.89 meters it traveled up. This one's going to be 91.89 meters, except it's traveling from the top to the bottom, so you got to remember this displacement has to be negative because the object is falling down that distance from here down to here. But now we can use this to find t. We would say then that d equals VIT plus 1/2 AT squared. D is negative 91.89. VI is 0, which is beautiful, equals 1/2 times negative 9. The 91 came from the fact that this object rose 31 meters from the 60 meters it started at. So now, from this perspective, it's 91.89 meters above the ground. You multiply this thing by 2, you divide it by negative 9.8, and you square root it. There was like half of you who forgot to square root it when we're not looking for t squared, we want t. It's going to be the square root of, maybe I should put it in here, 2 times negative 91.89 over negative 9.8. And you're going to get the time value here of 4.33 seconds. Now that is just the time it takes to get from the top to the bottom. So we have to add that to our previous time. And over here, we're going to get t total is 2.55 plus 4.33. We should get a time of 6.88 seconds. Liam, did you do the quadratic formula way?
I messed up with the values A, B, and C.
Gotcha. This is the value you're looking for out of the quadratic formula, 6.88. Now finding the horizontal range is trivial. You take that number, you multiply that horizontal component to find the range horizontally. It's a doozy, but it's doable. Questions, comments, concerns? Okay, then this is it. This is the last thing I'm going to try and teach you out of this chapter. Getting closer and closer to the real world. Does anyone have any questions about any part of this thing? Okay, and I got some questions I want you to practice. I was unable to put these questions into your book or I photocopied it, so I photocopied them separately. Hope that's not working. Gosh. Here are the questions out of here that you should take a look at. I want you to try question. Oh, there. I want you to try 2A. I want you to try 3A. Those two questions are exactly what we just did. I did an example of each. 2A is level ground, find the flight time and the range. 3 is what I just did too, find the flight time and the range. And then there's some more interesting ones. Question 4 is a gooder. And I don't want to get you guys through those. Save that for grade 12. That's it. Those 3. Yeah, we'll leave that alone. Just those 3. 2A, 3A, and 4. There you go.